Hello, and welcome to the Wild Space Podcast. I'm your host, Wilder Hogan Jr., and I'd like to thank you for joining me on this Sunday night. Today we'll be talking about physics, how it can save the world through space travel. Now, let's start on a very fundamental question. What exactly is physics? For today, physics is going to be the study of how the universe behaves and how matter interacts with each other. In a more simple way of saying it, physics is pretty much the rules of the universe. Why is physics so important? We need to understand the rules to play the game. The more we understand the rules of the universe, the better we can work around it, the better we can use that to our advantage. And that's exactly why for space travel, physics is so important. Physics determines every part of space travel, whether we know it or not. And the better we understand it, the better we can travel. Now, why exactly is space travel so important? Or not just space travel, space living, exploration, etc. We take resources from our planet every day. Our population gets bigger and we at times mistreat the Earth. So having a second home, potentially, or at least things we can explore, is very important to help save the Earth itself and saving humanity in case we destroy the Earth. Now, let's get into it. How can physics affect space travel at all? Let's start with some simple examples. Let's use Newton's laws, which are all very fundamental laws of physics, to determine how a rocket may lift off. Two very simple parts of a rocket liftoff is the rocket boosters blasting off the ground and flying into the air, and how much rocket booster we need to use to get into the air. And this uses both Newton's third and second laws of motion. For Newton's third law of motion, which is here, let me pull it up really quickly. I lost it. I do know. I just want to give it the complete law. For every action, there is an equal and opposite reaction. What does this mean? If you want to blast a rocket off the ground into space, you need to have something that creates enough power or force to do that. That's where we get rocket engines from. Rocket engines pretty much work by... Here, let me pull this up. I like to apologize, it is quite late. So a rocket engine is able to create thrust by pushing exhaust gas, very hot, very powerful, lots of force, into the ground, which propels the rocket upwards. We were able to calculate the exact amount of exhaust that we need to create, the exact amount of fuel we need to use by using Newton's second law of motion, that the force acting on an object is equal to the mass of the object times acceleration, also known as F equals mass times acceleration. We can calculate how much acceleration we need to create a force powerful enough to make it into the sky. Or vice versa, we can calculate how much force we need to get a proper amount of acceleration to go through the atmosphere and into space. There's also other examples of how Newton's laws of motions can be affected in rocket travel, and that is the first one, law number 1. A body at rest will remain at rest, and a body in motion will remain in motion unless it is acted upon an external force. How can we use this for space travel? Once we make it into space, in theory, we could move in a straight line. We could not use any force, no engine, no anything, and just continue to move in a straight line indefinitely, because as long as we're not acted on by another body of motion. Another force. Yeah. Sadly, there's tons of different forces in space, whether it be the gravity of another planet or just the gravity of the solar system. Because of this, scientists need to use Newton's laws of motion to calculate, correct trajectories for spaceships to make it into their proper destinations. This is why understanding Newton's laws of motion are so important to having safe and proper space travel. If we didn't understand these simple concepts, we wouldn't be able to blast off, and we may run into issues in space because of not considering these variables. Now, this is how physics affects rockets itself. How could physics maybe affect living in space in comparison? A big thing about living in space is that we need to understand what we're living in, and right now we just don't understand it too well. We do know many things about space and many places out there, but we need to see how everything interacts and how everything behaves, and because of that, the main way to do that is by exploring. a big example of this is the International Space Station. It is currently working with microbiomes, which are essentially zero gravity colonies of microorganisms up in space, and we are seeing how they react to different environments and different activities. And through this, we are learning many things. Again, we've never seen something like this, like how it behaves in space. So we're learning how, like, fundamentally these things work in space. This, at the end of the day, is biology compared to physics, but physics is pretty much the study of how things work and how the rules they work. So it kind of falls under physics. What benefits could this have for space travel? If scientists on the International Space Station and NASA are saying that this has potential of creating maybe micro farms, or could have the ability to break down precious metals in space, which, if we unlock, would just be a huge set of resources here for Earth if we are able to mine precious metals out of space, whether it be silver, gold, diamond, etc., just and be able to use it down here for other things, because on Earth those are limited resources. These are just a couple of ways that space travel can affect the world we live in now, even with like sciences we're figuring out today. So physics, the more we understand it, the more we can live in space. An example being, we were able to use Newton's natural law of relativity, gravitational relativity, to kind of understand how galaxies are built, how the universe itself is somewhat structured, and how solar systems can be structured. And using this, we can figure out different forms of gravity. But I think I messed that up. Using this universal law of gravitation, we can figure out how kind of like the universe moves and how it works. And using things like this helps us move forwards with our understanding of how we work. All right, let's find the part. Damn. I'm already 6 minutes in. I would not like to restart. So I'm gonna keep going. So physics is very important. It can save the world. It can save humanity, potentially. Let's say we have a extinction level event here on Earth, and the more options we have, the better.